Hello. In this video, I'm going to look at the inverse function a bit more. I'll continue with using this function x squared, or mapping x squared plus 5. We have seen that by sketching a graph of this function for this domain between x 0 and 1 and this codomain where we allow the answer to be between 4 and 6, we see that we have a graph that looks like this with a range that covers part of the codomain. If I want to think about the inverse function, it means that I need to find the inverse of this function. That means that if I'm given a value of this answer, I want to find the corresponding x. So let me try that. Okay. Now the way we can actually do it by algebra, I'll take this. I'll go through the steps quickly. Is to say that we are given. Let's say I have this inverse function. Let's say this inverse function of x, okay, is equal to y. Then if I want to find this inverse function, I say that x is equal to the function of y. So as I described, the answer y is the value that when I put into this original function would give me the x. Or we can just take it that this is what this actually means. In either case, we can now use this formula to solve for the function, the inverse function, or to find an expression for y. So let me put this y, substitute this y into this formula. This gives y squared plus 5, and if I rearrange this, I get x minus 5 equals to y squared, and I get y is equal to the square root of x minus 5, and it can be plus or minus. Okay. Now if I get plus or minus, then actually we have a problem, because as I described in the last video, a function must give a unique answer. But in this case it looks like my inverse function, which looks like what this would be, alright, has two answers, so it doesn't have a unique answer. But before we worry about this, let's come back to let's not forget that there is also the domain and codomain that we must think about. Okay. Now the reason why we have a plus or minus for a given x is because in this graph we have these two, we have this branch and this branch. We can think of these as the two branches of the graph. So if we imagine that the x here this time, that the y here corresponds to a value here, and the x corresponds to a value here, Okay, that's what the inverse function means. Okay, the graph as I've drawn it here is for y is equal to x squared plus 5. But in the inverse function, if you compare this with this, or if you compare this function with this function, you see that the rows of the x and y are reversed. Okay, if you compare these two. So what this means is that in the inverse function, if I imagine plotting the inverse function, it's as if I would interchange the x and the y axis. I would interchange the x and the y axis. So it's a bit like flipping the graph. All right, flip the x to the y and the y to the x. And the effect of this is as if I reflect this graph along, say, a diagonal line like this. So if I do this, let's see what the graph would now look like. Okay, remember now that I want to exchange those two. So this gives me so the y and the x exchange place, so that I get x equals to y squared plus 5 instead. Okay, so that this is my, I still call this x and y. Okay, but the role of the x and y in the formula is exchanged. So instead of having 5 and 6 here, I now have think about having a 5 and a 6 down here, and 4 down here, and 0 to 1 down here. Okay, so instead of having the curve like this, I would have a curve now that looks like this. I will have the curve here instead of that. So this curve has now come down here. Okay, and we can imagine that doing that by reflecting this along an axis, along this diagonal line. So this whole thing comes down here. If I imagine that calling that point A and that point B, so A comes down to here and B comes down to there. Okay, now but how do the domain and the codomain then come in? Well, domain here was 0 to 1. Now when we do an inverse mapping, the domain becomes the codomain and the codomain becomes the domain. Okay, so this means that I now have this 0 to 1. What was the domain is now the codomain. And what was the codomain from 4 to 6 is now the domain. Okay, so the part of the curve that I need to look at is this part, not that part, because that part did not fall in the domain. So this part of the curve is here, is this part. So I'm not supposed to look at this part. Okay, it's just this part of the curve. And now we can get a better understanding of this formula, of this plus minus sign. The plus minus sign here refers to these two branches. So if I take the plus sign here, I'll get this branch. If I calculate this, I'll to get a positive value. If I take the minus sign here, then I'll calculate a minus value for y, and that corresponds to this part here. So according to my original definition of domain and codomain, it means that I should only take the plus sign. Okay, so that helps us to understand the steps to get the inverse function formula more clearly, because obviously I cannot just just get an inverse function like that. I cannot just get the inverse function ignoring the domain and the codomain. Alright, as you can see, by thinking carefully about what happens to the domain and codomain, how they exchange place, we see that we have to take the plus sign. We are supposed to ignore the minus sign. So instead of having both plus and minus, the correct inverse function would be just the one with the plus sign. So this is my inverse mapping for the inverse function. Okay, but there is a problem. Actually, there is a problem. Okay, if you look again at this domain and the codomain, okay, you see that there is this part in the domain between 4 and 5, this part here, that does not seem to have any curve or graph above it. So it means that what happens if, let's say, x is 4.5? Then I don't have a graph above it to tell me what's the y value. And we can understand why from the equation, because if x is 4.5, if x is 4.5, I get 4.5 minus 5. I get 4.5 minus 5, which is, when x is 4.5, this gives me y is equal to square root of 4.5 minus 5, which is the square root of minus 0.5. A square root of a negative number. Okay, we have not learned it yet. We'll learn it later on under complex numbers, and we'll learn that this is an imaginary number. But for now, since we are just purely dealing with real numbers, since only real numbers are allowed in my domain and codomain, these values, square root of minus numbers, whatever I'm going to call it, they're not allowed. Okay, so these are not allowed. So what it means is that for some of the numbers in the domain, we don't have an answer. The mapping, this formula does not give us an answer for the inverse function. So in other words, no answer exists for the inverse function, and that is a problem, because one of the requirement for a function is that we must have an answer. The function must give us a value for all the x in the domain. Okay, so apart from what I described just now, if you remember, for a function, the properties of a function, the answer that I mentioned just now, that the answer that it gives must be unique. So now we need to add one more feature, that the answer must exist. Okay, in other words, we must have a value in the codomain for each and every one of the values in the domain. So which means that for this particular function with this codomain and this domain, an inverse function does not exist, because this doesn't satisfy the property of an inverse function. Okay, there are certain values in the codomain for which there's no answer. But we can actually be if we can be flexible, we can say that, right, we can actually think about adjusting this domain. Okay, if I adjust this domain so that instead of saying that the set of values I allow here is between 4 and 6, what if I shrink this domain so that it's just between 5 and 6. Now remember that this domain came from the codomain, and the codomain was just a set of values that I just made up. Okay, that I just made up to say that this is the set of values that I allow the function or the mapping to give an answer to. Okay, this is a set of values that I allow this formula to map onto. So I just made up a set of values. So I can equally well say that now that I really want an inverse function to exist, why not just shrink this codomain? So why not just shrink this codomain instead of saying that it's from 4 to 6? Let me shrink it from 5 to 6. Okay, so shrink this to this. So it means that now I shrink this codomain. I don't want this anymore. I'm going to shrink it to between 5 and 6. So this means I no longer have to worry about having an x between 4 and 5, because this is not allowed anymore. I've redefined my codomain for the original function. So for this inverse function or the inverse mapping, I also have a new codomain, this time between 5 and 6. And as you can see, there is always a graph above this range of x, above this domain. So now each and every value in the domain can have an answer in the codomain. So by shrinking or restricting the domain, we can now have an inverse function. An inverse function can now exist. So for a function, the answer must exist. So in this case, by restricting the domain, so we can think of this smaller domain. You can think of this smaller domain as a restricted domain. By restricting the domain, it is now possible to have an inverse function.